Hi to all. Today's topic is Taylor's theories for a function of two variable for a problem 3. The question has been given in this sin xy in the power of x minus 1 and y minus pi by 4. Okay, now x is a is nothing but it is 1. B is nothing but pi by 2. So when I write it, how I have to write f of x comma y sin xy. A from the given question A equal to 1, B equal to pi by 2. So at 1 comma pi by 2 we have to calculate. Okay, calculate it. Sin 1 into pi by 2. Sin pi by 2. Sin pi by 2 what it is? Sin pi by 2 is nothing but 1. Cos okay pi by 2. It's nothing but 0. Okay, this both only we will be using in this problem. So sin pi by 2 is 1. So f of a comma b is 1. So first order derivative first we will calculate. Second order separate. Both we will write in a formula. The first step fx is nothing but dou f by dou x. So when I calculate it, okay, sign differentiation when I do, it's nothing but cos. Correct? Sign differentiation when I do, it's nothing but cos of xy into what I have to do. It is a product of inside function I have to differentiate. Now with respect to x only I am doing. Y is a constant, x when I differentiate it is 1. So it is y into cos xy is the answer. Now at a point 1 comma pi by 2 we have to substitute it. 1 comma pi by 2 means for x 1. So 1 or y pi by 2. Cos pi by 2 it's 0. So full term fx is 0. Okay. Same way fy when I calculate it, dou f by dou y. Same thing sign when I differentiate it is cos only. Cos xy. Now with respect to y. So x is constant, y when I differentiate 1. So it is x into cos xy. Now same way when I substitute in this, so cos of x is 1, so pi by 2 into x, so x is 1, so cos pi by 2 0, so total fy also 0 I am getting. Same way f double x for a second order term. It's nothing but dou squared f by dou x squared. Now dou by dou x of this function. So y into cos xy. Okay. Now you check in this y is a constant only. So y is a constant. Cos only differentiation is nothing but minus sign xy into inside function. Y is a constant. X when I differentiate it's 1. So what answer you will be getting? Minus y squared sin xy I will be getting. Substitute at 1 comma pi by 2 when I substitute it. Okay, when I substitute in this. So sin minus y squared is nothing but pi by 2 the whole squared into sin 1 into pi by 2. Pi by 2 is nothing but 1. So the answer will be minus pi squared by 4 is the answer for f double x. Okay. So f double y. So again dou squared f by dou y squared. When I do it, dou by dou y into now dou f by dou y answer. So x into cos of xy. X is a constant because we are going to differentiate with respect to y only partially. So x is a constant. So cos when you differentiate, what answer I'll be getting? Cos when I differentiate, I'll be getting minus sin xy, okay, sin xy into, now we have to differentiate with respect to y only. So x is constant, y when I differentiate 1. So answer will be minus x squared sin xy. Now substitute at 1 comma pi by 2 is substitute. In this when I substitute it, minus pi minus x1 I have to substitute, minus 1 into sin pi by 2. Sin pi by 2 it's nothing but 1. So total answer will be minus 1. So completed. Same way, now I have to do it for fxy. Same procedure, fxy. Dou square f by dou x into dou y is nothing but dou by dou x into the same function x into cos xy. When I do it, now uv. Remember, both are involved with respect to x. uv, what is our formula? U into v dash, v into u dash. That only I am going to do. X as it is, cos when I differentiate minus sin xy into y as a constant, x when I differentiate 1. Okay, completed. Cos xy as it is. Okay, you have confusion means you write a bracket. Cos xy as it is, x when I differentiate it is 1. So now in this you substitute at x comma at 1 comma pi by 2 you substitute it. So it's nothing but minus pi by 2 into sin pi by 2 plus cos pi by 2. Cos pi by 2 it's 0. So you'll be getting the answer to be minus pi by 2. Okay, completed. Now you write a Taylor's theorem formula and substitute in this. So it will be completed. Now I will write the formula. So formula when I write it, what is our formula? F of x comma y is nothing but f of a comma b plus x minus a into fx plus y minus b into fy plus 1 by 2 into, write the answer here. So when I write it, 1 by 2 into 1 by 2 into, so x minus a the whole square into fxx plus y minus b the whole square into fyy plus 2 into x minus a into y minus b into fxy, close the bracket, plus etc. This is our formula. Now we substitute it. F of a comma b already calculated, it's 1. Okay, 1 plus x minus a, so it's nothing but x minus the corresponding fx is 0. Correct? Here it is 0. Fy also it is 0. Okay, so full term 0. Only 1 by 2 will come. Okay, so 1 by 2 because the full term is 0. Both 0, 0. Only in this term. So 1 by 2 into x minus 1 the whole square into fxx is nothing but minus pi square by 4 plus fyy is nothing but minus 1. So minus y minus b is nothing but pi by 2 the whole square into minus 1 plus 2 into x minus 1 y minus pi by 2 into minus pi by 2. So plus etc. This you need means you can separate it and write. Okay, the last part I will separate it and write. Okay, when I write it. Okay, so this I can separate it and write. Minus symbol you will check, here also minus, here also minus, here also minus. Throughout minus I will take it outside. So when I take it outside, it's x minus 1 the whole squared. Already 2 here. Pi squared divided by 8. I will write it. Okay. Completed. This term you check. So it's nothing but already minus symbol. So minus y minus pi by 2 the whole square divided by 2. Here already this 2 get cancelled. So minus symbol taken outside. So minus. Okay, one more 2 will be there. Minus x minus 1 into y minus pi by 2 into pi by 2. This 2 will be there. So completed. This is our final answer. You need means you can expand it and write or leave it as it is. So completed. Plus etc. Next question. Fourth problem. So what is our fourth problem? I have taken different question so that you can okay, which is easy I have not taken, which is complicated only the question has been taken. So now you check, expand e to the power x into log of 1 plus y in the power of x and y up to second order. If it is given like this, power of x and y means at a at a point means it is a 0, 0 comma 0. What is the meaning? A equal to 0, B equal to 0 only. It will be given like this. X and Y if it is mentioned means at a point 0, 0. So what is our question? F of x comma y is our question. It's nothing but e to the power x into log of 1 plus y. Okay. Now at a point you have to substitute. So f 0 comma 0. When I substitute it, e to the power 0. Everyone know that it is e to the power 0 is nothing but 1. Okay. So log of 1 plus 0. So log 1 is nothing but it's 0. Log 1 is 0. These are all everyone know. Okay, log 1 is 0. So overall f also 0 at a point. Now first order first I will do. Same way second order. All both we'll substitute in the formula. So first order term, it's nothing but fx. Fx is nothing but dou f by dou x. So now x only. Log of 1 plus y is a constant. E to the power x, when I differentiate, e to the power x only. Now when you substitute at a point 0 comma 0. At 0 comma 0, it's the same thing. At 0 only you will be getting. Okay, same way fy. Fy is nothing but dou f by dou y. So log, now e to the power x is a constant. E to the power x is a constant. Log we have to differentiate. Log when I differentiate, it's nothing but log, it is a any log. Log differentiation, it's a dou or d. Okay, differentiation partially or log of any variable. Same x is nothing but 1 by x. Okay, same way 1 by 1 y. Okay, 1 by 1 plus y. Now you check 0 here, e to the power 0, 1. So 1 will be the answer at a point. Same way when you do it for second order derivative. Dou squared f by dou x squared, it's nothing but dou by dou x into e to the power x log of 1 plus y. When I differentiate, log of 1 plus y is a constant. E to the power x, when I differentiate, e to the power x only. Okay. At a point 0 comma 0, your f double x will be same thing 0. Log 1 0, e to the power 0 1. So 0 only. Okay. Fxx is 0. Same way fyy, when I do it, dou squared f by dou y squared. So dou by dou y into e to the power x. Now this you write it as 1 plus y the whole power minus 1. Okay. Now differentiation e to the power x, e to the power x only. It's a constant. So now with respect to y we are doing So 1 plus y the whole power minus 1, what it is? So minus 1 into 1 plus y the whole power minus 2 into inside function 1 only. Okay. So this is our answer. Now in this you substitute at 0, comma 0. So fyy will be, check it. Fyy will be e to the power 0, it's 1. So minus already is there. So here y 0. So 0 means 1 only. So minus 1 is the answer. Fyy is minus 1. Same way, fxy. Fxy is nothing but dou squared f by dou x into dou y, dou by dou x into e to the power x into 1 plus y the whole power minus 1. When I do it, this is constant because x only we are doing. E to the power x is same e to the power x only. E to the power x divided by 1 plus y. Now at 0, comma 0. So fxy 0, comma e to the power 0, 0. E to the power 0, 1. So here 0, so 1. So fxy is 1. So calculated. So now we will write Taylor's theorem formula and then substitute it. So write the Taylor's theorem formula. What is our formula? F of x comma y is nothing but f of a comma b 1 into x minus a fxx y minus b into fy 1 by 2 into x minus a the whole square into fxx plus y minus b into the whole square fyy plus 2 into x minus a y minus b into fxy plus etc. Now when I substitute it, a equal to 0, b equal to 0, that you remember it when you write it. F of a comma 0 comma 0 is 0. Okay, need not write at all. So now in this fx you check, fx also 0. This also 0. Fy only we have. So b also 0. So fy means y into correct. B also 0. Y as it is y. Fy answer is 1, only y. Plus 1 by 2 into, same way when I write it here, a 0. So x squared into fxx 0. So 0 only. Fyy is minus 1. So minus plus itself I will write. Y squared into fyy is minus 1 plus 2 into x0, a0, b0. So xy, 2 into xy. Fxy answer is 1. So you write it now in the simplified form. F of x comma y is nothing but the answer is y minus y squared, correct? Y squared by 2. Y squared by 2. In this 2 get cancelled plus xy plus etc. So this is our answer. We are getting in a very simplified form. The last problem in the Taylor series. So the fifth problem, expand e to the power x into cos y at 0 comma pi by 2 up to second order term. Okay, now so the question is, we'll write down the question again. F of x comma y is nothing but e to the power x into cos y at 0 comma pi by 2, it is given in the question. For this we have to know what is cos pi by 2, sin pi by 2. Okay, cos pi by 2 and sin pi by 2. So what is your cos pi by 2? Cos pi by 2, okay. So it's nothing but cos pi by 2 is, what is the value? It is 0. Sine pi by 2 is nothing but 1. We will check. So now when I substitute in this, e to the power 0, e to the power 0, it's 1. Okay. Into cos pi by 2. So it's nothing but 0. Okay. Now first order term and second order term separate. Then we substitute in the Taylor's formula. So fx nothing but dou f by dou x. So check it. X. So cos y is constant. E to the power x is e to the power x only. So fx you are going to calculate it. So fx when I do it e to the power 0 it's 1. E to the power 0 at remember at 0 comma pi by 2. Okay. Cos pi by 2. So it is 0. Now fy dou f by dou y. Same way e to the power x is a constant. Cos y differentiation is nothing but sin y. Now substitute it e to the power 0 into minus sin pi by 2. Sin pi by 2 already I told it is 1. So minus 1. Same way fxx dou square f by dou x square. So now with respect to x only we are doing. So e to the power x, I same e to the power x only, cos y is constant. So I will be getting 0 only. Okay, at a point. Okay, f y by dou square f by dou y square. Okay, y square means this one more time with respect to y. E to the power x is constant. Okay, sin y is nothing but cos y. So e to the power pi by 2 is nothing but 0. So 0. fxy dou by dou x into minus e to the power x into sin y. Because we are differentiating with respect to x, e to the power x is same e to the power x only. So minus e to the power x into sin y. Sin pi by 2 it's 1. So it's nothing but minus 1. So completed. So you write we have to write the formula then substitute it. So what is our formula? Taylor series formula. So f of x comma y is nothing but f of a comma b plus 1 into x minus a into fx plus y minus b into fy 1 by 2 into x minus a the whole square into fxx plus y minus b the whole square into fyy plus 2 times of x minus a into y minus b, okay, into fxy plus etc. Now substitute it. F of a comma b already calculated, it's 0. This is 0. This fx is 0. Any other thing is 0. F double x also 0. Fy by fy minus 1. Fy by 0. Fxy minus 1. I will substitute in this. So when I substitute it, what answer I will be getting? So only in this I will be getting. This also 0 in this. Okay. B is nothing but pi by 2. So it's nothing but y minus pi by 2 into minus 1. In this 1 by 2 into both are 0. Only this term I will get. Already 2. So 2 into x only I will have it. X minus 0. Right? Here 0. A is 0. B is nothing but y minus pi by 2 into minus 1. Now you simplify it. We can write it in a simplified form. Y minus pi by 2 in both the terms are taken outside. That also you can take. If it is, I'm able to take it outside means we can take it, no problem at all. Okay. So y minus pi by 2, you check in the question, you can take it outside. Minus symbol also in both. So that also I will take it outside. When I take it outside, I'll be getting 2 get cancelled. 1 plus, in this only left out is x, 1 plus x. That's all. We are getting in a very simplified form. So like this you can simplify it or leave it as it is. The given question itself we can leave it. Thank you.